Thank you very much for attending this session. Today, I'm going to talk about break-even analysis simulation. In general context, in deterministic break-even analysis, we have a fixed cost, which is fixed over the time horizon, for example, 1 year. We have a variable cost, which is fixed per unit of product. Therefore, total fixed cost is fixed no matter how many units do we produce, at least over the period of our study. And total variable cost increases linearly, and we assume linearly, as production goes up. We also have revenue, total revenue, which is price multiplied by quantity sold, and that is a straight line too. And we assume there is no quantity discount or market segmentation and things like that. Total revenue is also a straight line. Here in simulation, we assume each of these have a range. For example, fixed cost has a range of 800,000 to 200,000. Variable cost per unit of product can range from 180 to 220. And product price can range from 350 to 450. Now we want to see what will happen to our profit, to our loss, when do we break even, what is the probability of break even, and so on and so on. Let me first copy this page into the next page. For simplicity, we assume all random variables follow uniform distribution. And to make it simpler, we assume they follow discrete uniform distribution. Therefore, we can simply use Excel function of rand between and we can generate them. Suppose we want to generate 1,000 random numbers. I type here 1, right click, go down, come up, leave, series, in a column, go from 1 to 1,000. I do this to make my copying easier. So that's it. Fixed cost is equal to rand between 800,000 and 1,200,000. And because I want these numbers to stay fixed, I lock row 1 and row 2, but I leave B as a relative reference because I can then copy to the right for the variable cost and for sales price. That's it. So that is rand between those two numbers. And click. I have generated 1,000 random variables, and I can delete this column. That was just to make that copying down easier. For variable cost, I can just copy this to the right. For price, I can just copy this to the right. And suppose we know that our sales quantity is something between 4,000 and 8,000. I copy this one to the right too. So this is a rand between those two numbers. And this is rand between those two numbers. Click. Now my total cost. What is my total cost? Total cost, fixed cost, does not depend on the volume of production. So that is fixed cost plus variable cost multiplied by number of units produced. And in break-even analysis, we assume quantity produced is equal to quantity sold. Production is equal to sales. No inventory, no back order, no leftover. Total cost is fixed cost plus variable cost multiplied by quantity sold. That is my total cost. Total revenue is equal to sales price multiplied by quantity sold. This is total revenue. Profit is total revenue minus total cost, and then click. So now I have all this information equal to, let's see what is our average profit, or if we have profit at all. Average and I lock it because I'm going to copy it down to make my job a little bit easier. For standard deviation, I copy it down, double click on it, STD deviation of sample. That's it. Coefficient of variation is equal to standard deviation divided by average. Median, I just copy this, bring it here, and then I make it median. Max, mean, range, maximum minus minimum, count. We know it is 1000, but still you like to have it here. 95% confidence interval, confidence norm. If it is 95% confidence, therefore alpha is equal to 1 minus 95%, which is 0.05. Standard deviation is here, and count is here. So this will give us a confidence level. Say with 95% confidence, you can assume that your profit is between this. And lower confidence interval is average minus. Higher confidence interval is average plus margin, 95% margin. And probability of profit equal to count if these numbers, comma, quotation mark, greater than or equal to 0, quotation mark, enter. 689 observations where profit was greater than or equal to 0. Let me remove that. It was not due to 0, it was due to the random numbers which are continually changing. See? Random numbers are changing and always give us something close to that estimate. And I divide it by count to get probability. That's it. So probability of profit is 27%. Now equal to sort. Sort, and I sort these numbers from the smallest number to the largest number. So now it is sorted for me. Now I come here and say equal to, I want to draw a curve when on the horizontal axis I have profit or loss, and on vertical axis I have probability. Rows from here to itself. And I put a dollar sign in front of the first four. Enter. Click, click. It will write 1 to 1000. And then if I divide it by count and lock it, it will give me the probabilities. Click, click. And this is the curve that I have got. This is simply like this. Insert. Scatter graph. Here it is. or I can change this, okay? And I can control 1, make it a little thicker, for example, like this. I can format this axis up to 1 because I don't go more than 1. This is a graph. Now I have it here. I can go back to this page. It tells me that with 68% probability you are making profit. It will go up like this. You may lose 549,000, or you may gain 1,130,000. Average of your profit is 188,000, and probability of profit is 68. If you like, I can also type equal to, and here all formulas. So now, instead of just having one number, this is break-even point, we can provide more information for the person who wants to make the decision. In my next talk, I will go through the same data, but instead of a S-shaped curve, I will create a histogram, and I fit normal distribution. Thank you very much for paying attention to this session.